materials, we discuss about the unit 3, that is analysis of stresses in two dimensions. In this topic, we have to discuss about the thin cylinders, thick cylinders, and about the spheres, and also we have to analyze the principle of stresses, that is Mohr circles. Okay, these all the content we will discuss in this topic. So let us discuss about this topic, thin cylinders. Okay, so what is mean by thin cylinders? The thickness of the wall of the cylinder vessel is less than 1 by 15 to 1 by 20 of its internal diameter, that is L by D ratio. Okay, so length 2 is diameter, the value should be is 1 by 15 to 1 by 20. Okay, then the cylinder is said to be a thin cylinder. Okay, so in the thin cylinder, the stress distribution is assumed uniform over the thickness of the wall. Okay, that is one of the assumptions you have to made it. Okay, so this is the thin cylinder vessels subjected to internal pressure. Okay, so D is the internal diameter of the thin cylinder, and T is nothing but thickness of the cylinder wall, and P is represent the internal pressure. Okay, when the fluid or gas is something, any medium is flowing inside the cylinder. Okay, there should be some pressure is created. Okay, so that pressure is the internal pressure. Okay, then length, L is nothing but length of the cylinder. Okay, so this is showing in this figure, and the stresses in a thin cylinder vessel subjected to internal pressure. Okay, when the pressure is, when the fluid or some medium is flowing inside the cylinder, there should be some stresses generated inside the cylinder. Okay, thus stresses are tensile. Okay, that stresses are tensile. Okay, that should be classified into two types. One is the circumferential stresses, that may be called as a whoop stress. Okay, the another one stress is the longitudinal stress. Okay, so what does it mean by circumferential stress and what is mean by longitudinal stress, we discuss now. Okay, when the stress acting along the circumference of the cylinder, okay, the stress is acting along the circumference of the cylinder. Okay, so that is the circumferential stress. Okay, this is the figure A that represent the circumferential stresses. Okay, then the longitudinal stresses. Okay, the stress acting along the length of the cylinder is known as longitudinal stresses. Okay, so figure B is showing this is the longitudinal direction. Okay, so that is the longitudinal stresses. Okay, the formula to find out the circumferential stress and the longitudinal stress is, okay, this is the figure. Okay, so the formula to find out the circumferential stress, that is PD by 2T. This is the formula. P is represent the pressure inside the cylinder, D is the diameter of the cylinder, and T is nothing but thickness of the cylinder. Okay, so this is the sigma 1, that is sigma 1 represent the circumferential stresses. Okay, so that is PD by 2T. Okay, and longitudinal stresses, okay, that is PD by 4T. The longitudinal stress is nothing but is CA sigma 2. The sigma 2 represent the longitudinal stresses, that is PD by 4T. Okay, that is 2 times of the that is half of the circumferential stresses. Okay, the longitudinal stress value is always being the half of the circumferential stresses. Okay, so here on some discuss about the sum. A cylindrical pipe of diameter 1.5 meter and thickness 1.5 centimeter is subjected to an internal fluid pressure of 1.2 Newton per mm diameter. You have to determine the longitudinal stresses developed in the pipe, and also you have to find the circumferential stress developed in the pipe. Okay, the cylindrical diameter is, the diameter of the cylinder is 1.5 meter and the thickness is 1.5 centimeter, and the stresses acting inside the cylinder is 1.2 Newton per mm square. So So discuss here, this is the L by D ratio, that is a 1 by 100 which is less than 1 by 20. Okay, so this is comes under the thin cylinder. Okay, the L by D ratio, sorry, L by D ratio, okay, this comes to thickness for T by D ratio is 1 by 100. Okay, this is less than 1 by 20. Okay, so the thickness to the diameter ratio is 1 by 100 which is less than 1 by 20. So that's why its name is called thin cylinder. Okay, for the thin cylinder we have to find out the longitudinal stress and circumferential stress. We already discussed about the longitudinal stress formula and circumferential stress formula. The longitudinal stress formula is half of the circumferential stress. The circumferential stress formula is PD by 2T and the longitudinal stress formula is PD by 4T. The pressure value is given already given in the sum, that is 1.2 Newton per mm square. The diameter value is also already given in the sum, that is 1.5 meter, and the 4 that is derived from the expressions, and T that is thickness of the cylinder. Therefore the final value to find out the circumferential stress is 30 Newton per mm square. Longitudinal stress is 30 Newton per mm square. Next one is the circumferential stress. The circumferential stress formula is PD by 2T. That is pressure value is given in the sum, diameter value is given in the sum, and the thickness value is also given in the sum. Finally, the circumferential stress value is 60 Newton per mm square. Okay, similarly we discuss about the second sum, but in this sum, the second sum, we have to find out the internal pressure of the gases. How much pressure is inside the gases? Okay, that is the value you have to find out. The internal diameter is 2.5 meter and the thickness is 5 centimeter and the tensile stress in the material is 80 Newton per mm square. Determine the internal pressure of the gas. Okay, so the tensile stress in the material is not to exceed, that is the maximum stress of the cylinder is 80 Newton per mm square. Therefore we consider the maximum stress where should be applicable only in the circumferential stress. Okay, because the longitudinal stress is half of the circumferential stress, therefore we consider the stress is the circumferential stress. Okay, therefore the formula to find out the PD by 2T. Okay, so the PD by 2T is here. Okay, substitute the value of given value in this formula and find out the pressure. The final value of the pressure is 3.2 Newton per mm square. Similarly, we go for the next one. The cylinder of internal diameter is 0.5 meter. Okay, contains air at a pressure of 7 Newton per mm square. That is a gauge pressure. If the maximum permissible stress induced in the material is 80 Newton per mm square, the maximum permissible stress is nothing but that is circumferential stress. Okay, find the thickness of the cylinder. You have to find out the thickness of the cylinder. Okay, internal pressure is given, the circumferential data is given, and also given the internal diameter. Okay, you already know the format of the circumferential stress. The circumferential stress equal to PD by 2T. Therefore substitute the value of the pressure, diameter, and the thick. Okay, and circumferential stress and find out the value of the thickness of the pressure. Okay, that is 2.188 centimeter. Okay, this is the actual thickness of the cylinder for the given data.